we are going to put all this knowledge into action. So what I'm going to be doing here is I'm going to be using my existing infrastructure here. So this is what we have already done. R5, R4, R2, R6. They're already running MPLS and we are good there. So what I want to do is I want to add R7 in VRFA on R5 and R8 in VRFA on R6. Now, I should just point out that the reason why I'm using VRF names that are the same on both sides is because I'm lazy. And the reason why I'm using A as the name on both sides is because I am really, really, truly lazy. So there is no requirement for these names to match or to be this short or anything of the sort, but I really wanted it this way. Also, on R7 here, I will be using route distinguisher 56.5, and on this side here, I will be using 56.6. Route target, and this will be route target export, will be 56.7, and on this side it will be 56.8. So what I will be importing here will be 56.8, so whatever I'm exporting on the other side, and what I'm going to be importing here will be 56.7. Also, just for fun, I'm going to configure this side using the old method, and this one I'm going to configure using the new method, just so that we can see that one in action. So I'm going to bring out my routers here. I'm going to connect to R7 and R8, and what I'm going to do actually is I'm going to move R7 all the way to the left here, so that at least visually my tabs there on top resemble the layout of the network. So whenever I'm configuring my MPLS VPNs, these are the steps that I like to take. First, make sure that MPLS infrastructure is in place. Now, this should actually be step number 2. Step number 1 is create VRFs and associate interfaces. Now, why is that first step? Because this is really part of layer 2 setup, right? And I really want to be done with layer 2 setup at one point at the very, very beginning of my lab scenario before I actually do anything else. Now, MPLS infrastructure in place, this involves IP routing and MPLS backbone. Step number 3, VPN v4 infrastructure. Basically, MPBGP peerings. 3, PE/CE routing. 4, MPBGP and PE/CE redistribution. And here I will point out not needed if PE/CE is eBGP. 5, ping and happiness. So these are the steps of configuring the MPLS VPN. So let's start there where I promise I'll start. So I'm going to create the VRFs and associate appropriate interfaces. So I'm going to start from R5. So on R5 here, let me bring up my text editor here. I'm going to say IPVRFA route distinguisher 56 whatever that was, and the route distinguisher there is 56.5. So 56.5, I will be exporting route target. Route target export is 56.7, and I know that I will be importing whatever is on the other side. So this is going to be the configuration on R5. And then interface fastnet 00, I'm going to say IP VRF forwarding A. So this is the configuration that I will have on R5. So this is going now to R5, and I seem to have a question right now, so let me take a look. Oh, it wasn't a question, it was actually a comment that I have 2 exports, and that is entirely correct. So let's just correct this to be import. Thank you very much. So this goes to R5. So I'm going to paste this in, and this is what I wanted to show you. It says here that interface fast Ethernet 00 IP address 10575 was removed due to enabling a VRF-A. What was the net mask on this interface? Well, we can take a look at this and answer that our net mask, oh, it's supposed to be 24. But that wasn't my question. My question wasn't what is supposed to be the mask. My question was what is the mask, or what was the mask. If we take a look at the startup configuration, we will see that the actual mask that was configured was /25. Now, it should be /24, but I just wanted to illustrate the danger of running this command blindly, because all IP-related configuration from the interface will be removed when you actually enable VRF forwarding on the interface. So what we really want to do is, before we configure the VRF on the interface, just quickly show run interface that you are running this on. Just make sure that you can see what is already configured, so that when you actually put this command in, that you at least have things to copy paste from. So this was the configuration on R5. Now let's do the configuration on R8. So here we said that we are going to be using the new command set. So I'm going to say VRF definition, and I'm going to specify name. So this is going to be A. Here I can specify the route distinguishers and route targets, and I can specify the address family. So I'm going to specify the route distinguisher. What was supposed to be the route distinguisher here? 56.6. And then I'm going to go into the address family, and here I have 2 options, IPv4 or IPv6. And I'm going to say route target export, and it was 56.8. And I will be importing 56.7. So if I do show IPVRF, I can see here that VRF-A is now configured with 56.6, but I do not have any interfaces actually associated with this. Now, I should point out, and this was one of the questions that I had in the break, when you configure the VRFs using this new configuration, so show run VRF, when you use the VRF definition here, that when you do show IPVRF, this VRF does not show. Well, it won't show unless you actually enable it for address family. So let me just show you that very briefly. So I'm going to say no address family. Actually, I just did no VRF definition A. Okay, that's not exactly what I wanted, but VRF definition A, route distinguisher 56.6. So now if I do show IPVRF, it won't show because this VRF is not actually enabled for IP, right? It's just defined, but it's not active in the IP address family, but in IPv4 address family. So what you can see it with show VRF, and here in the protocols section, it will tell me for which protocols, is it IPv4 or IPv6 that it is actually enabled on. So let's enable it for IPv4. So I'm going to say VRF definition A, and I'm going to say address family IPv4. And if I do show VRF now, I will see that it says that this VRF is now enabled for IPv4, and now it is actually also visible with show IP VRF. And here let's do the route targets. Export 56, I keep forgetting this, 8, and route target import 56.7. So now this is the configuration of our VRF, and this is using the new method. So now I'm going to go and, learning from my mistake, I'm first going to take a look at the interface. So interface fast Ethernet 00. Here I'm going to say VRF forwarding. Now I can still do IP VRF forwarding, and that would be fine. But if I do IP VRF forwarding A, that applies only for IPv4 traffic. If I wanted to have IPv6 traffic in this VRF as well, I should really use the new method. And here I'm saying VRF forwarding, and I'm specifying the name of VRFA. And now I can actually copy paste and configure this. So if I do now show VRF command, I will see that VRFA using the RD of 56.6 is enabled for IPv4 and is active on interfaces fast Ethernet 0.0. I can also do show IP VRF, and I'm going to be seeing it like this, except now I don't have this protocols line here. I can also use the command show run VRF to see the running configuration of the VRFs, but please don't get too used to this command, because the version of iOS that you will have in your CCIE RNS version 4 lab does not support this command. So I am a little bit lazy, so I am using it because it's a very useful command. It will show me the actual configuration of the VRF and all the interfaces, the routing protocols, and the relevant MPBGP configuration for that VRF. So it gives me very, very quick overview over what's configured for that VRF. So now let's take a look at, oh, hold on a second. I was configuring a completely wrong device here. Oh, I was configuring R7. I should have been configuring R6 for this. Oh my, oh my. So let's remove this VRF. So no VRF definition A. And this is where the value of copy paste is now going to become apparent. So what I'm going to do here, paste this in. Let me put this IP address here. So let's go to R6. So what I need here, this is what I need to do. This was really, really silly oversight on my side. But anyways, very easily fixed. So this goes on R6. On R7, I should have this in the main routing table, show IP route. So I should be able to ping 10575. That works. On R5, show IP route VRF A. I should be able to ping R7. That works. And on R6, show IP route VRF A. Should be able to ping inside VRF my router 8. That works. And on router 8, it's show IP route. I should be able to ping R6. So what I have now in place is that this VRF is defined and I have the communication between 5 and 7, and this VRF here is defined and I have the communication between R6 and R8. Now, the next step in my checklist here is to have, so I've done this. Now, MPLS infrastructure is in place, so there is an in missing there. So MPLS infrastructure is in place. That is done. We have already configured that a long time ago. So now we have to build the VPN v4 infrastructure. So that means that I have to go ahead and build my BGP configuration. So that's what I'm going to be doing. And let me just bring in the, actually this picture here. So I need to build BGP between R5 and R6. Now the good news is that they're going to be in the same autonomous system. So I'm going to start with my usual way of configuring BGP. So I'm just going to say IP BGP community, new format. I'm going to say router BGP, let's say 56. Then I'm going to say BGP upgrade CLI, because this is what I always like to do. And then I'm going to do another thing that might be a little bit controversial. I'm going to say no BGP default IPv4 unicast. Now, what this command here does, it does change the behavior of BGP. Because by default, when I define a neighbor, so for example, if I went in here and I said neighbor 192.168.0.6 remote AS 56, this neighbor will automatically be activated in IPv4 address family. Now, because in this scenario here, I do not need IPv4 peering between R5 and R6, I'm just going to say, you know, that automatic IPv4 peering, don't do it. If I need it, I'll define it manually. So this is what this command does. It is going to prevent the iOS from automatically activating this neighbor in the IPv4 address family. I don't need it. Now, the next thing that I'm going to say is update source, going to be peering between the loopbacks, and then we go into the address family. So address family, I need VPN v4, and I'm going to say neighbor this activate, and what is going to be entered, so I do not need this command line because this will be entered for me and I cannot remove it. This is the command that will send extended communities like route targets. VPN v4 cannot operate without these extended communities, but I like the ability to use standard communities as well, so I'm going to say neighbor send community both. So this is what's going to be in there, as opposed to what is there by default. Actually, there was an error here that should have been send community extended, right? So what I'm going to do is I'm going to replace that with send community both. Now, this is the configuration for R5. Now, interestingly enough, this is the exact same configuration that I will need on R6, except with this. Now, some of you might be looking with a puzzled look on your faces. What is he doing here? Well, let me show you what I'm doing. I'm going to go to R5, and I'm going to paste this configuration in. Now, take a look at this. R5 here is complaining that it cannot configure itself as the neighbor. Good, I don't care. Because I'm going to paste the exact same thing to R6. Now, R6 is complaining that it cannot configure itself as the neighbor. Do I actually care about that? No. The only thing that I care about is that it took me a couple of seconds to clone this configuration and then just do paste, paste. If I had 5 routers, it would have been paste, 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 right? So I am speeding up. I don't care about that tiny little error that iOS is going to throw at me. Now, there is one more thing that I want to show you. So right now, if I go to R5 and if I do show IPBGP summary, I'm not going to see anything. And this is exactly the thing that I wanted to show you. Now, show IPBGP summary here doesn't show me anything because this is an old BGP command. The new BGP command that is equivalent of this is show BGP IPv4 unicast summary. Now, of course, I'm not going to see anything because I don't have an IPv4 peering between these neighbors. So if you do show IPBGP summary and you see the neighbors and you're thinking, oh, my multi-protocol BGP is okay, you are not actually checking that. You are checking whether your IPv4 peering exists. And IPv4 peering doesn't carry VPN v4 routes. Question here was just to clarify why I had this thing here configured on R5 and R6, and the answer is just, I went through it. It was just for the speed, so no other reason, right? You don't have to do this. It's, you know, if it's confusing you, if you think that this might be wrong in some way, then don't do it. But the important thing here is that it's not actually going to end up in the running config. So on R5, there will be only so let's do router BGP. What you are going to be seeing is going to be only the statements that are actually relevant. All those self-neighbor statements, they were immediately rejected by iOS. That's why it's safe to use them. But going back to what I was just saying, this command here will show you, or show IPBGP summary, will show you the status of currently non-existent IPv4 peering session. Now, it's very dangerous when you are troubleshooting MPLS VPNs to run show IPBGP, see the session, and assume that your MPBGP is okay. It's maybe okay, but maybe isn't okay. The command that you need to remember is show BGP VPN v4 unicast all summary. Now, what all stands here is all VRFs. Now, at this point here, is where we are seeing the actual session going on. So right now we can see that neighbor 192.168.0.6 is our neighbor for version 4, so this is what we can see here, in the AS56, and that we are receiving 0 prefixes here. Now, I should also point out that in a case that you have IPv6 routes, this would be the session that you will be running, in a case that you have VPN v6 routes. But this is most likely not going to be the case in the lab. Now, there's one more thing that I want to show you. Let's say that, for example, R6 here was actually configured to have the neighbor in IPv4 session. Oh, sorry, so needed towards R5. So now the neighbors are going to go down and so on. So if I go to R5 now, and if I do show BGP IPv4 unicast summary, I'm not going to see anything because R5 is now not configured to have IPv4 peering with R6. But let me show you what's going to show up on R6. So show BG, or let's do the more familiar one, show IPBGP summary. Take a look at this. Now, this could also be the case if you have, for example, IPv4 peering between them that is active, but only one side is configured for VPN v4 peering. On that side, if you ran the command to see VPN v4 peerings, if you see this error message here, no neg, that basically says this address family with this neighbor is not negotiated. It's activated on my side. So this is R6. So on R6 side, we have activated the neighbor, but the other side is not actually responding to a peering request in this session. It's not negotiating this address family. So if you have this error message, and this is very relevant for the troubleshooting section, if you have this message here, when you see the summary of the neighbor, that means that this address family is not negotiated by the other side. It is configured on this side, but not on the other side. The side that doesn't have it configured will be showing absolutely nothing there. So this is just one thing that I wanted to show you. I will leave it in the configuration there, even though it's slight misconfiguration, but just when you get the file so that you can actually take a look. At this point, we are done with our VPN v4 infrastructure. We have configured MPBGP peerings. There are no routes carried, but that's okay because there are no routes being advertised. Now we need PE-CE routing. So let's configure some PE-CE routing. Here, between R5 and R7, let's run, for example, EIGRP. So this is going to be EIGRP 57. And here between R6 and R8, let's run, for example, let's run BGP. So this is going to be in AS, let's say, 800. So we are going to run AS 800 here. Let's start with EIGRP side. Actually, let's start with BGP side. So I'm going to go to R8. Now, from R8's perspective, this peering here is going to be just a regular IPv4 peering. Now, from R6's perspective, this is going to be peering in IPv4 VRF A. So this is where I will need to configure peering on R6, and this is where I'm configuring peering on R8. As far as R8 is concerned, this is just regular BGP. So going to my notepad, I'm going to start with R8 because it's probably going to be a little more straightforward. So actually, most of this stuff actually applies. I won't be needing this. I can reuse a lot of this stuff. I won't be needing update source, and the address here will be 10686. So this can be actually copied. I can paste it here. I can paste it here. And let's just redistribute connected. So R8 is just going to redistribute all the connected routes. So we have to get some routes in our BGP, right? So this is going to be the configuration on R8. So let's do that on R8. Oops, looks like okay. It works much better when you actually click in the window where you want to paste. So this is now configuration on R8. On my R6, the configuration is going to be, this is 56. I won't be needing this. This is already configured. I won't be needing this. So this now goes into the address family. Address family IPv4 VRFA. And this is now 8. This is 800. And I don't need redistribute connected. So this now goes to R6. At this moment, my BGP peering should come up. And from R8's perspective, if I do show IPBGP, this is what I'm seeing. I'm seeing 2 local routes. So from R8's perspective, this is just a regular peering. So all the regular BGP commands simply work. And here I can see that I do have the neighbor 10686 in version 4, autonomous system 56, and I'm receiving 0 prefixes. On R6, if I do show IPBGP summary, again, I'm not going to be seeing anything because this is not IPv4 session. Well, if I want to see this session, I have to do show BGP, show BGP, VPN v4, unicast, VRFA, summary. A lot of typing. So, you know, if you think that this is a lot of typing, what you can do is something like this. So we can say sib all or sib VRFA summary, but personally I don't like using aliases. But if you think that typing all this stuff is too complicated, by all means configure the aliases and feel free to use them. Just as a good measure at the end of the lab, if you have time, remove them or simply make sure that they cannot interfere with the grading. Which is the best way to ensure that they cannot interfere with the grading is not to use them in the first place. So right now, if I do my show BGP VPN v4 unicast or unicast VRFA summary, I see that from R8 I'm receiving 2 routes, and if I do show IP route VRFA, I'm actually going to see one of these routes in the routing table. Why one? Well, because the other one is this connected route here, but it is still going to be in my table, but it's going to be with the RIB failure, just like the regular BGP. Now, one difference is that here I'm going to actually see the route distinguisher. So these routes here, actually when advertised to other routers, will have this route distinguisher prepended at this point here, somewhere before them. But you're not going to see that in show output, only in debug outputs. The only place where route distinguisher shows in BGP outputs is when you see this. Now, if I go to R5, if I do show BGP, VPN, v4, unicast all summary, I see that these 2 routes have actually made it all the way to R5. Now, they made it all the way to R5 because if you are using eBGP as the PECE routing protocol, and we did mention that here, if you are using BGP as PECE routing protocol, it's not needed to do any redistribution, right? But if you are using any other protocol, we actually do have to redistribute. So we can see that these routes have made it across, and if I do show IP route VRFA, on R5, I will see 2 BGP routes. A significant thing to note in this output is the next hop. The next hop for BGP learned routes, for the routes learned from MPBGP, inside the VRF will actually be the peering address of the MPBGP session, even though it is known in the main routing table. This is a perfectly legitimate output to see. So if you are troubleshooting reachability between your CE routers and you see this and you might be thinking, hey, hold on, but I don't actually have the route for this in the VRF, this is normal and this is perfectly acceptable thing to have because this is how MPBGP works. So this is okay to see as the next hop here. Now, if I go to R7, where we are not yet running EIGRP, of course, I'm not going to be seeing any routes. So let's configure EIGRP between R5 and R7. The configuration on R7 side, in this case, is going to be very straightforward. This is just a regular EIGRP. So router EIGRP 57, no auto summary, and I'm going to say network 0000 simply on all interfaces, and I'm going to run this here and enable EIGRP on R7. Now, the configuration on R5 is going to be slightly more involved. What I need here is I need to define address family IPv4 VRFA. And then inside this VRF, I need to specify which is the autonomous system number to use. Now, this may look redundant because I have already specified 57 here, but the idea is here that you can have a container process. The process that, may have multiple address families that needs to have configuration-wise an AS number specified, but that inside autonomous system you can run different autonomous systems in different VRFs. So this is the reason. So that's exactly why I'm going to configure it like this, to show you this difference. But even though these would be the same, even if I had 57 here, I still need to specify it, because if I don't specify it, the EIGRP is not actually going to be active inside this VRF. So this is a mandatory line when you're configuring EIGRP inside the VRF. So this is now the configuration that goes on R5. So this goes in. Oops, out on. It helps when you spell it correctly. And now we can see that EIGRP actually came up. So if I do show IP route EIGRP on R5, I'm not going to see any routes. Why am I not seeing any routes? Well, because the routes that were actually received from R6 here over the MPBGP between 5 and 6 are now sitting in the VRF routing table as BGP routes. Now, BGP routes are not automatically going to be advertised into EIGRP. If you want to advertise them into EIGRP, you have to redistribute. Hence, this step here that we actually need to perform PECE redistribution. So, also, it is true that on digress. On R7, I'm not going to see any routes. On R5, show IP route VRFA, here I will actually see an EIGRP route. But what I was talking about before, I just made a slight mistake on which router it is happening. On R7, I'm not going to see any EIGRP routes because they are not being redistributed from MPBGP. For the same reason, on R6, show IP route VRFA, I'm not going to see any routes learned from R5 because those EIGRP routes, or that one EIGRP route, actually needs to be redistributed into BGP. So let's do that. I'm going to start with R5. What I'm going to do here is I already have this. So what I'm going to say is redistribute BGP 56. And I need to specify the metric again. I'm just going to make it very, very easy for me. Oops. Wrong router. Let's go to R5. So here I'm going to redistribute BGP. So now if I do show IP route EIGRP, I'm going to be getting those two routes from R8. Now, let's redistribute in the other direction. So I'm going to have router BGP 56, again, address family IPv4. And here I'm just going to say redistribute EIGRP, but this time I need to specify the actual process number that is, or autonomous system number that is running inside VRF. So this goes now on R5. So when I do this, if I do show BGP VPN v4 unicast VRFA, I should be seeing these two routes. So this one here, which is directly connected one, and this one here that was learned from EIGRP injected into BGP, which means that if they are injected on R5, I should be seeing them. Show BGP VPN v4 unicast VRFA, unicast VRFA, yeah, that's correct. So I should be seeing them here, and again, they will have the next hop of R5 in the main routing table. And if I do show IP route VRFA, I should be seeing these two routes now learned on R6. Now, because these routes are already BGP routes, there is no need for any redistribution. If I go to R8, if I do show IP route, I will actually get these two routes in the routing table. The last step that I need to do here is to actually ping and make sure that it actually works. The question that I was asked here is it a good idea to use the VRF upgrade command? Now, what does the VRF upgrade command do? So let's take a look at that command. So if I go to the config mode and if I say VRF upgrade CLI, now here what I'm going to be offered is to upgrade from the old configuration mode to the new multi-address family mode. Now, this is very similar in operation to what BGP upgrade CLI does, but here I'm going to have a couple more options. One is to use the common policies and the other to use non-common policies. Now, what does that actually mean? So let's take a look at the VRF here that we have on our file. So if I do show run section IPVRF, so this is where we used the old configuration mode. So when translating this from the old configuration to the new configuration, we have two options what we can do. Now, one possible translation of this configuration would be, this doesn't work for some reason. Anyways, one possible translation is to use VRF definition A and then say route distinguisher 56.5 and then simply transport this here and use it as global policies and then activate address family IPv4. Now, this would be the option when we would be using common policies, and we can see this in the online help. It says IPv4 VRF policies are moved to common VRF policies, which means that these policies here will actually apply to address family IPv4 and address family IPv6. Now, another way of translating this, and which would result in the equivalent configuration to what we had before, would be to actually translate this as this. So that these policies here that were used inside this VRF are not automatically copied for IPv6. That means that they are not common policies, but that they are moved only into the sub-address family for IPv4. Depending what you want to do, one or the other might be a good option to do. Now, the real question there was, should we do this? Well, why? Unless you are planning on actually having IPv6 VRF in your network, I don't believe that there is a reason to actually use this. So it's an interesting command to know, and this behavior with common or non-common policies is an interesting to explore, but I don't think that in the exam you should worry about using this command. So if they ask you to use the new format of defining VRFs, I mean, you should do it. They might ask you to upgrade, but then you might need to know this command, but you know, I don't think that it is likely that you will ever have the need to actually use this command in the CCIE lab.